guys are like first session, right? You have your lap. Do you have your laptop? All right. So can you just open your laptop? Okay. So yesterday we were discussing about strings. Okay, we'll discuss this separately about string. Okay, and just to summarize, strings are nothing but it is a collection of characters. Strings are immutable. Immutable means it cannot be changed, right? And then we have looked into the functionality of strings, right? Similar to strings, are you able to see? No, I think you have to shift. Fine, right? Now, similar to string, there is another data type called list. Okay, what a list? List of Python is very much flexible compared to other languages. Array. In other languages, we have a concept of arrays, right? In other languages, arrays are very confined. It can store only one type of data. But in case of list, we can store collection of data of different types, right? So list is nothing but a collection of list is a collection of objects. So I can define anything inside a list. Okay. I can define anything inside a list. List are collection of objects. How many objects we have in Python? Everything is an object in Python. Whatever concept you come across is an object. Right? Python is 100% object oriented language. Pure object oriented language. That means everything in Python is an object. How to identify whether it's an object or not? Whenever you create anything in Python or whenever you come across anything in Python, just check what is the type of that. So it is coming as class list, right? If this is coming as a class list, which means L is nothing but L is the object of the class, right? Are you guys aware of Hooks concept? Little bit idea? No? Hooks concept? No? See, class is nothing but you can understand class something like a prototype or blueprint, right? When you construct anything or when you build anything, right? Before building, first you design. right? First you plan how you're going to build, right? Before constructing even this building also, there was a plan, there was a design on paper, right? The design is a class. You can call the design as a class because the design defines the characteristics and the behavior, right? Characteristics means what is the height of the room, size, color, material. These are the characteristics. Behavior means this room will be used for uh, teaching. This room will that room will be used for uh, like counseling, right? So they have defined some behavior also for the room, right? Right. So class is a collection of characteristics and behavior. Characteristics are nothing but the properties, attributes of the entity. Okay, behavior are the functionality. Okay. Class always contains two things. It contains characteristics and behavior. Always. Okay. Now to create a class, we need to use a keyword called class, followed by class name, colon, and then define the functionality. What functionality we want to put under this class. If I just ask you what is the why do we need a class? We need to understand that part also, right? Why do we need a class? Why can't we go without creating a class? So class is just to create the segregation, right? There are features available for let's say chair, right? And then there are features available for us, right? So I'm creating a software and I'm defining some feature which is available for which is specific for users, and then there are some feature which are specific for payment, right? Now profile picture can be changed by the user, right? But product is not something which will change the profile picture, right? So we need to segregate the features, the functionality of one entity with another entity. And class is creating the layer of segregation. So we create a class and define all the relevant feature inside that class, which is relevant to that class, right? What is the characteristics of a let's say this chair? If you want to list down all the characteristics and behavior, then it has color, height, width, material, brand name. These are the characteristics, or in technical terms, these are the properties. Right? What is a behavior? Is nothing but your functionality, which will be setting or writing. Right? So these are the functionality. Now, if I do not group this, if I don't put this under one group, right, then this can be used by anyone, right? So we are creating a group. That group is known as a class, and all this feature we put inside that class. Now, once you create a class, you have to create the object. You have to become the member to use the feature of that class, right? That means we all are the member of class human being. We all are the objects, right, of class human being, because each one of us have name. Value is different, name is there, right? Similarly, all these chair are the object of class chair. Every chair have all those features, Implementation design might be different, right? But those properties and features are available, right? So that creates a layer of segregation among the by creating classes. And once we create class, to use the class, we have to create objects. Object creation is object name equal to class name. It is as simple as this in Python. Give your object name equal to the class name. This that will create the object of the class, right? Once I create the object of the class, then I can do o dot, and I can see in the drop down whatever we have defined in the class. I'm able to access those. Is this part clear? Okay. In Python, everything is a class. There's nothing called data types in Python, right? We are calling data types, right? But these are not data types. These are the classes. And then there is nothing called variables, because all the variables are the objects, right? So the inline concept of Python, the inline concept of Python is class and object. Anything you go and look into Python, right? Anything like if you go to Django also, Django, data science, AI, all the packages, frameworks in Python, every framework is running in the same format. They have defined some classes, and we are calling those classes as library today or framework. Okay. And then the interesting point here is all these classes, this we have discussed in first session, but yeah, most of you are like new, right? So the interesting point here is all these classes, whatever you come across, right? If you go and check the type of the class, print type of list, it is pointing to class type. And when you check the type of type, now this you do with any class. I try with integer. That is also pointing to class type. I try this with string. right? So this is a structure that's how Python is running. We have some objects, right? That object comes from class. Class can be of any kind, any type of class. That class comes from, so there is nothing beyond class type. Okay, there is nothing beyond class type. You just need to understand only OOPS concept. You just need to understand how to create a class, how to define the feature inside the class, how to create the object of the class, and how to use the feature. These 4 points you have to learn, right? If you if you're clear with these 4 points, you're done with Python. Because every concept is coming up under these 4 points. For data type classes, Python community have already created these 8 classes: int, list, string, tuple, dictionary, right? We call this as a data type. So for these data type classes, first and second point is done. Like class is created, features is defined. What we are doing is we are doing the third and fourth point, creating the object and using the feature, right? Clear, right? If that is the case, then list. So how do we create the object of the class? Object name equal to class name. How to create the object of list class? List object. Object name equal to, give, tell me some object name. Any object name. Hmm? L, okay. And how to create the object of this list class? I want to create list object. Object name equal to class. What is the class name for list? Uses our class, right? Custom class. Class name for list. Hmm? List only, right? List is the class name. Class list, right? So list is the class name for list. This creates list object. That means whatever you do here, this is a shortcut. This is not the actual way. This is the actual way. Define some value over here. This in ID, like in Jupyter Notebook, without print, like it executes in this tool. But when you write your actual application, right, then yes, you have to give print. Clear, right? So shortcuts are applicable only with the data type classes. Once we move out of the data type classes, right, then shortcut will no more work. You have to go with the actual approach. Actual ways, object name equal to class name. So you should know what are the class name we have, what are the classes we have. Now, whenever you come across a new topic in Python, try to understand which class it is pointing to, or whether it is a class or a function. If it's a if it's an object of a class, then go and check what is there in that class, right? Uh, just to show you guys how does a class look like. So here, when I do L dot and tab button, I'm getting this drop down, right? From where all these things are coming? Inbuilt function, but from where it is coming? Which class it is coming from? List class, right? Just now we have seen we have created a class user, and inside user I have given name and age. When I created the object of user, o dot, I was able to see name and age in the drop down, right? So if you do reverse engineering here also, we are getting this in the drop down with when I do L dot, L is nothing but object of this class. That means whatever we see in the drop down is coming from the class, right? So now let's see what is class list. This is my list class, and it contains append, extend, pop, index, count, insert, remove. All these are nothing but these are the methods, functions which are defined inside this class, right? Hence, and what we are able to, what we can do once we create the object, we are able to see everything in this front door. That means we are able to access the feature of that class by creating the object of the class. Without object, you cannot access, right? So if you go back and if I check, we have class string. This is my class string. Capitalize, case fold, center, right? This is what we have seen yesterday, right? Ends with, find, format, everything is a method, right? And this is one of the reason why Python is easy to learn. Because there is only one concept you have to learn, right? And this is the reason why Python has so many libraries. If you look at Python, creating a library in Python is very simple. And that's where Python is being used everywhere. You see the usage of Python. What is it? Those are coming from class list. Now you feel like, no, I don't want to create this. I don't want to use this. I want to create my own class. You can create your own class called class list version 2, right? Yeah, and then use the list as a base. On top of that, you can do some kind of customization and start using it. We'll see that once we get into OOPS concept, right? We'll see how to create custom classes, how to inherit, how to override. Those concepts we'll see. But for now, just to go with this initial concept. Understanding about the class and object is very important because every time we'll come across this OOPS concept. So Python is pure object-oriented language. If you go and check other languages, C Sharp and Java, those are partial object-oriented. Right? There we have a concept of data types. Right? So in those languages, functions are known as a first-class object. Right? So your objects are considered from functions. But in case of Python, from data type itself, you see objects. Okay. Fine. So list is a collection of objects. Now we know that everything is an object in Python. That means inside list you can store anything. Right? You can store anything inside a list. When I try to update, by the way, list also supports indexing. Right? Indexing starts from 0 from left to right, and from right to left it is -1, -2, -3. It also supports slicing. I can give 0 colon 2, right? So gives me the first two index. That means starts with 0 and go till 1. 2 is not included, right? So the same concept of slicing is applicable in list also. Right? Slicing will be applicable in any collection, and list is one of the collection, right? Now if I try to update the value, in string we were getting error, right? String object does not support item assignment. But in case of list, it is updating, right? If I try to delete, in string we were getting error. String object does not support item deletion. We cannot delete, right? But here we are able to delete, which means lists are mutable. Lists are mutable. Mutable means after creating the list, we can go and change the list. Okay. Once the list is created, I can add more items to the list. We can delete existing item from the list. We can update the list. We can reverse. We can do sort. All these operations are supported, right? Now to add more items to the existing list, there is a function called append. What does append do? Append takes an object. See, append takes an object, which means you pass anything to the append function, it will take and insert at the end of the list. Yes, it takes and insert at the end of the list. Okay. If I want to add somewhere in between, then there's something called insert, where you pass the index and the data. It will get inserted in that index. Even insert takes any object. That means you can pass any type of object to the insert. Okay. There's one more variety which is your extend. Extend takes only iterable. Objects are of two types, iterable and non-iterable. Iterable means collection. Non-iterable means single data. Right? So out of this all the data type classes, what do you think? Like what is integer? Integer is iterable or non-iterable? Integers are non-iterable because we never said that integers are the collection of digits. Integer contains always single data. So integers are non-iterable. What about float? Float is also non-iterable. Boolean, Boolean is will also be non-iterable because it contains true false. It does not contain collection of data, right? List, iterable. String, iterable because in Python strings are collection of characters, right? So strings is iterable. Tuples are iterable. We'll see what tuple is. Tuples are iterable. Dictionaries are iterable, and sets are iterable. That means integer, float, and boolean are non-iterable object. In extend, we cannot pass non-iterable. It takes only iterable. That means I cannot pass integer here. It will give me error. Right? Let me try passing string. What does extend do? Extend does not insert the object as it is. It starts taking out the item from the collection and then start at appending. So it goes like this. That means it did not insert hello as one object. It started iterating, it started taking out one item from the collection every time and then insert. Okay, so that is the difference between extend and right. So this is the difference between extend and insert, right? Then we have something called pop. What does a pop do? Pop will delete the last item by default, right? If you are not passing any index, then it deletes the last item, right? If you want to delete something from between, or then we have to provide the index number. right? And pop operation, right? Whenever you see any operation named pop, right? Pop means delete and return. So it always count, you'll get the deleted item as a return value, right? Something like take out and throw on the screen. We also have remove, where you pass the data object and then that object will get removed, right? But remove is not going to remove all the objects, only first occurrence from left hand side, right? So we had two occurrences and it remove only one, the next occurrence is still there. So again when I call remove, then it will remove the next occurrence. So there are three ways of adding. First is insert, then we have append, and then we have extend. There are two ways of deleting, pop and remove, right? Now we have count. What is the count? Do you pass the pattern? It will tell you the count of it, how many times that pattern is present. Same. This is the same function that we have for string. In string also we have count, right? So count, I'm checking how many times 30 is available. So 30 is there only once. So I'm getting the count is 1. The number of occurrence of that object, what you are passing. Okay. We also have index. Index will give me index will give me the position of the pattern from left hand side. So where is 10? It's at 0, 1, 2, index number 2, right? When I check index of 10, I get 2. I get the index of that pattern. So it will start searching from left hand side. 0, 1, 2. Either multiple 10, still it will give me 2. The first occurrence from left hand side. Okay. Then we have something called index count and reverse. Reverse will flip the list. Okay. There is no output of the reverse. So when I do L dot reverse, it is not returning anything. Right. So I have to print L to get the item. But it goes and change. Okay, we have something called clear. What does a clear do? It will remove all the data. What is the difference between clear and delete? When I do clear and del, now if I delete the entire list, not one item, but entire list, then what is the difference between clearing the list or deleting the list? Clear will just clear the data, my list will still exist. List object L will still exist in the memory. When I execute this and then I try to print L, it will remove the list from the memory. Okay. There's something called sort. Sort will arrange the list in the ascending order. If it that is not possible. Sorting can be done only with one kind of data. Clear? If you want to do the sorting in the descending order, then we have sort reverse equal to true. It does in the descending order. Okay. So what are the methods we have append? There are three ways of adding the item to the existing list, right? Append, insert, and extend. There are two ways of removing the item: pop and remove. Then we have count, index, reverse, sort, and then clear. Okay, copy we'll see later. It's basically there are two types of copy, so we have to understand what are the two different types of copy. There is shallow copy and deep copy, right? So with that concept, we'll cover copy later. But apart from that, these are the feature of list class, right? Simple, right? Similar to list, there's something called tuple, right? Tuples are denoted by parenthesis, right? Tuples are denoted by parenthesis. Tuples can also contain collection of objects similar to list. The only difference between tuple is it is denoted by parenthesis, not square bracket. Okay, and it is coming from a class tuple, right? And the major difference is tuples are immutable. That means we cannot change. After creating a tuple, you cannot change the tuple. Right? So if I do L of 0 equal to 90, it will not allow. Now, what is L? L is the tuple object, right? When I'm trying to change the first index of the tuple, it gives me error, does not support item assignment. If I try to delete, even that is not allowed. Okay. Yeah, I'll come to that point. I'll come to that point, but it's purely depends on the memory. List consume more memory. Okay. Now, when you have a requirement, when you are not changing anything, right? Then why to consume more memory in the artist, right? So there we make use of tuple, right? Now in tuple, like since tuples are immutable, whatever methods we have in tuple, right? Like we have append in list. What do you think? Like, can tuple have append? No, right? Because it's immutable. We cannot append anything inside a tuple, so append cannot be there. What about insert? Even insert cannot work because it is immutable. Tuples are immutable, right? Extend, same. Extend is also like it will not work because we are appending something, right? Pop, deletion will also not work. Pop and remove. Count, count will work because count is not changing anything. Index, index will also work. Reverse, reverse is changing the position of the data, right? So that's not going to work. Clear? No. Sort, even sorting will not work because your index will change, right? You cannot change anything. Now when I look at the tuple L dot, as simple as that. It supports only two functions, count and index. You cannot do anything else. right? That means inside tuple class, they have not defined anything. They have just defined these two functions. Now you go and define more function, then you can make tuple mutable. Okay. And we'll stop here. Tomorrow we'll continue with the tuple. Like I'll show you that memory allocation, right? And then we'll continue with the dictionaries.